All right, so this question relates to CAPM, but it's actually a walk in the park, and you may see it as a multiple choice question on your exam. However, some students fail to understand the very simple steps to this question, and we're going to try to go exactly through this. Do you need formulas really for this type of questions? Maybe not, but it's really important to understand the frameworks at play. So let's walk through it together. You'll see how I think about these questions, and now you'll know how to solve an amazing exam-like question. Slightly more complicated than what you'll see in an exam, though. Let's get through it. Alrighty, Sarah, that's a nice name, would like to invest in a portfolio with a beta of 0.528. So already here, we know that the beta of the portfolio is equal to 0.528. When I do exam questions, even to this day, well, I'm not a student anymore, but when I used to past, I started using my helps, I would always identify stuff. It's always really important to identify what you're dealing with. Let's start with that. Let's go with the basics, okay? So it then says, how should she divide her funds? Okay, how should she divide her funds? It's an interesting idea. Divide her funds between the risk-free asset and the market portfolio, okay? This is interesting in order to achieve her goal. So we want to know what proportion of her money, of Sarah's money, should be allocated. So what is the weight of the risk-free rate? And what is the weight of the market portfolio in order to achieve a beta? Oh my God, I'm so sorry. A beta for her portfolio of 0.528. So I guess there is a formula that we want to look at. And I talk about it so often, but it's really, really, really important. And once again, within CAPM, there's only a select few formulas to really get a grasp on. And this one really remains to be among the best. So it's the formula for the portfolio beta. And you can write the portfolio beta as essentially being, and I'll maybe take a step back. You could write the portfolio beta, so like this, as being the weighted sum of its individual assets, okay? But this kind of doesn't sound, it doesn't really make sense to most students. And we could literally break this down into something that's a little bit easier, such that the beta of a portfolio can be written as this following, like this, it can be written as like this example, okay? It works pretty well. You could say that the beta of a portfolio is equal to the weight of asset A times the beta of asset A plus the weight of asset B times the beta of asset B plus the weight of asset C times the beta of asset C plus 3 little dots to highlight continuity, to assume that we're going to continue this series forever up until the nth asset. And we could display it as being the weight of asset N times the beta of asset N, okay? So this is how we literally talk about something related to the beta of a portfolio. This is the go-to formula. But in this question, we're talking about a portfolio that only deals with 2 assets. So technically, we would only need this portion of our formula. One asset, so asset A, and the other asset, asset B. In this example, we have clear names for these assets. They're very specific assets that make this easy for you. And you may be very confused that they gave us such little information, but we actually don't need that much information for this question. So we can write that the beta of a portfolio, right, would be equal to the weight of RF times the beta of RF plus the weight of the market portfolio times the beta of the market portfolio. And you may be like, dude, I don't know none of this. I don't have the information on this. But what's funny is that you actually do have all the information pieces you need. All you need to do is either have it on your cheat sheet or kind of be at the point where you understand and memorize these pieces of information pretty well. So we do have the beta of the portfolio, right? Remember, we highlighted it right here. It's right here. We do have it. And the weight of RF, well, that's what we're solving for. And the weight of the market portfolio, well, technically, we know that a portfolio could only be 100% invested, right? It has to be equal to 100%. The sum of your proportions of funds invested in a portfolio has to be equal to 100%. So technically, we could actually say that we're only solving for one variable, right? We're only solving for either the weight of RF or weight of M, like oh my God, I can't speak English. Simultaneously, okay? But before we get to that step, I'll take one step backwards, okay? what is the beta of RF? You should know this by now. The beta of RF is equal to 0. The reason why the beta of RF is equal to 0 is because, think about it, beta measures to what extent does the variance of one asset contribute to the variance of the overall market. But the risk-free rate does not have any like classical variance that actually contributes to the variance of the market. They don't move in like any direction, like vis-a-vis each other. Okay, and for that reason, the beta of RF is equal to 0. So we understand that. We already know that. And then, of course, we understand and we know what the beta of the market portfolio is. Once again, beta measures to what extent does one asset's variance contributes to the variance of the market. In other words, if we're looking at the beta of the market portfolio, we're literally assessing to what extent does the variance of the market portfolio contribute to the variance of the market portfolio. Come on, this should be simple. Of course, the variance of the market portfolio contributes fully, right, at a mirror image of the market portfolio's variance. And for that reason, if we do the math, if we do the proof, you would see that the beta of the market portfolio is equal to 1. So just like that, you actually have all the information you need. You know that this, and I'll write it like in a different color, you know that this is equal to 0. You know that this is equal to 1. And we know what we need to do for these different weights, right? This would be X, this would be Y. We could actually simplify this in a way that's easier for us to like compute. So we would say that in order for us to gain 0.528, we could say that we're going to have X, right, times 0. I guess X times, we'll kind of stick, we'll do it. Yeah, we'll do X times 0 plus 1 minus X, right, times 1. Okay? So in other words, you would really just have 1 minus X has to be equal to 0.528. In other words, X would be equal to 0.472. Okay? And if you remember, we said in this example, well, like in the way I did it, we said that X is the risk-free rate, right? Such that you would need to be invested at 47.2% in the risk-free rate. This is a question that should be a walk in the park on the exam, okay? Really, really, really simple. You don't need a lot of computational power for this one, but it is a multiple choice that I've seen like myself actually on the past exam, if I'm not mistaken. Not like this, but I definitely have seen this somewhere. So very important to understand how to do this. You get good exposure. Hopefully this helped you out. And if you go through Eastman Helps' website, you will find really like an abundance of things, especially after September 2022. That's where all of my updates, hopefully I'm not dating this video, at least some of them should be there, and I'm working towards that. But for sure, as time progresses, more free content will be available to you. And this is just one step towards that. I really want to make this something that works and something that helps business students across, wherever, at all times. So yeah, hopefully this was helpful. Happy to help, and have a good studying process.